Hello students, this is Mr. Maat with another physics lesson. In this lesson we will focus on one experiment that is called Hooke's law. I will help you to figure out if force can be measured with a spring. Well, you need to download an app for this and I will show you that later on, but for next lesson there is a bit of homework, so make sure you do the homework of lesson 2.2.5 from Classroom. To begin with, you need to start clicking on the link that is given below. It's a link that brings you to Phet Colorado. That's a website where you can find all kinds of really cool simulations. We're going to use those simulations during the next physics lessons, so make sure you get familiar with the website. I will guide you step by step to the experiment. Well, the first step is this one. You need to click on the link and select Intro. The simulation will open. Then you need to click on Natural Length and you also need to switch on the movable line. You leave the spring constant of spring 1 on number 3 and set the spring constant of spring number 2 on 6. There is also a question formulated: what is the value for G? And G represents the gravitational field strength. And what is G here on Earth? Okay, so this is the website of Phet Colorado. Click on Intro and the simulation will open. On the left side you see spring number 1 and on the right side you see spring number 2. They both have a certain spring constant, and in this case they are both the same. I want you to leave spring number 1 on position number 3 and move the spring constant of spring number 2 to number 6. So 3, 4, 5, 6. And you see that the spring is changed a bit. There was also a box over here on the right side. You see the natural length. That was one thing that you should switch on, and that actually shows you what the length is of that spring. You also need to click on the movable line and you see there's a red line over here, and that one you can move up and down. Well, the first question was, what was the gravitational field strength here on Earth? Well, that value is of course that 9.81. You probably heard of that one. It's a constant number that doesn't change here on Earth. It's an average. The Earth is given over here and it's already set on 9.81. You can also change it to another planet if you want to do that at a certain moment yourself. Okay, step number 1 has been done, so let's go to step number 2. Step number 2. Several blocks are given, some with a value for the mass, some without. Create a table like the one below and fill in the mass and the gravitational force working on blocks 1 up to block number 3. So the thing that you need to do is you need to fill the value over here, this one and that one. So the mass, you need to convert the mass from grams into kilogram, and after that you need to go from the kilograms, how many newtons is that? Yeah, so what is the weight working on that block? So please stop the movie for a minute and try to copy this table yourself and fill it in. If you did it correctly, you should get values that look like this. First of all, if you want to go from a mass in grams and you want to go to kilograms, the first thing that you need to do is divide it by 1,000 and you get this value. I do the same for block number 2 and block number 3. So the only thing that I did is I took the value in grams, divided it by 1,000, and I get the value in kilograms. Now you need to calculate the weight working on those objects. Well, the formula to calculate the weight is the formula that is formulated in this box. Fg, that is the weight, equals the gravitational field strength G multiplied by the mass, lowercase m. Let's fill it in. Well, G is a constant number, that is at 9.81, and the value is already converted into kilogram, so I'm going to fill it in over here, and you see I get a value in Newton. Make sure that you always use standard units in your formulas with physics, because if you filled in grams over here, the outcome would not be in Newton. So standard units are very important. So here's the value for block number 1, block number 2 and 3 are given over here as well. So that was step number 3. Copy the table below in your notebook. Place a block on spring 1 and measure the extension. Place the same block on spring 2 and measure the extension as well. Repeat this for all blocks and fill the table. So please stop the movie for a minute and try to fill in this table. So it doesn't matter with which one block you start. I'm just going to start with the biggest. So I take this one of 250 gram. I place it on the spring number 1. If I release it, you see that the spring starts bouncing upwards and downwards. Yeah, I want to stop that, so I click here on this button over here, and then it will stop. And now the spring is just hanging there. So I want to measure the extension, and the extension means, well, we have the starting length, and we want to know, well, what is the extension? How much longer did the spring get? Well, then you need to know at which point you're going to measure. So I get rid of this one again, and you see that my blue line runs through this black dot over here at the bottom of the spring. So that's going to be my measuring point. Yeah. So take the 250 gram again, stop it, and now I'm going to move this red line up to that same spot. And I think the value should be somewhere over here. Maybe a bit more, a bit downwards, somewhere over here. Again, try to be as accurate as possible. This is physics. Now you take the ruler. Well, here's a ruler, and let's call this blue line my 0, because that is just the length of the spring. So I'm going to place my ruler exactly at that blue line over there, and now I'm able to read what the extension is with a mass of 250 gram. The extension in this case is 41 millimeters or 4.1 centimeters. Well, you do exactly the same with spring number 2. So you take this value of this block, place it over here, see how it stretches, and now move the red line exactly at that black dot. And in this case, the value is 27 millimeters, 2.7 centimeters. So here is my table that I filled. So here are my values for the different blocks that I put on spring number 1. And here are the values of the extension on spring number 2. And you see there is a difference. There is a difference over here. This one 3.9 and this one 2.7. And the same weight is working on that spring. So there is a difference between those values. And you see those values on the right side of spring number 2 are always smaller than the values on spring number 1. It doesn't matter if you have slightly different values. This is physics and we always make slight mistakes, so maybe you figured out that the extension was 3.8 centimeters. For now, that's not a problem. The next thing that I want you to do, you need to use the values from your table to calculate the spring constant of spring number 1 and spring number 2. So how to deal with this? Well, this is Hooke's law, and Hooke's law tells you the following thing. The force working on the spring, in this case it's the weight, because that was the force pulling on the spring. So the force in Newton equals the spring constant multiplied by the extension with a capital X. So if you take the value you want to calculate the spring constant, what you need to do is you get the formula force divided by the extension equals the spring constant. So please stop the movie and fill this table. Well, I calculated the spring constant for spring number 1. With the first situation over here, I got a 0.61. I did it with the second one as well. Same value. With the third one, exactly the same value again. And that's not very surprisingly for me, because it's called the spring constant. That means it should be a constant value. So I did a pretty good job over here. Now I'm going to calculate the spring constant of spring number 2. I see I made a mistake. This should be a 2, of course. So now I take the value for the spring constant, 2.7, and I'm going to use this gravity force again. Divide it and I get 0.90. And you see there is a difference in those two values of spring constant number 1 and spring constant number 2. Now the second one, it gives me an outcome of 0.89. It's not exactly the same as 0.90, but it's pretty close. Yeah, so this value, I did a pretty good job again. The last one is 0.98, and that's a bit off, but it's still pretty close to 0.90, so I'm satisfied with that. I probably made a mistake by reading this value of 0.5 not accurate enough. Okay. Step 6. The spring constant is a constant value for a spring. Which of the two springs is the toughest spring and which of the two springs is the weakest spring? Please stop the movie and give answer to this question. Well, if we look at those values again, you see that spring constant number 1 has a value of 0.61. Spring constant number 2 approximately 0.90. That means that this value is bigger than that value, and if that is the case, well, then the bigger the value, the tougher the spring is. So the toughest spring is spring number 2. Step number 7. Plot two graphs, spring 1 and spring 2, in one diagram. Place the force on the horizontal axis and the extension on the vertical axis. Only use the values of block 1, 2 and 3 and then you draw a trend line. Make sure you add also a point 0.0 because if there is no force working on the spring, there is no extension. So please stop the movie and draw those two graphs into one diagram. If you did that correctly, you should get something that looks a bit like this. Force gravity is put on the horizontal axis in Newton and the extension on the vertical axis in centimeters. I also gave my graph a name, the weight versus the extensions of two springs, spring number 1 and spring number 2. Well, I also drew a trend line and the trend line, well, connects the dots almost. You see that this one is a bit off and we already saw that in the table. So that's correct. Step number 8. The graphs can be used to determine the weight working on blocks 4, 5 and 6. At the beginning you saw that block 4, 5 and 6, they had a question mark on it. It was not clear what the mass of those blocks was. Well, we're now going to figure out what is the weight, so the gravity force pulling on block number 4, block number 5 and block number 6. What you need to do is this. You need to draw a dotted line from the extension up to the graph. When you hit the graph, you go vertically down and you can read Fg for each block. So I'm going to show you that over here. So the thing that you need to do, you just pick some kind of a value, maybe a value that was already in your table. I took 1.2. I draw a horizontal line up to the moment that I actually cross the line of the spring. So in this case, spring number 1. I go vertically down and at that point I can read the gravity force working on that block. Well, that's the way you should do it for those values of block number 4, 5 and 6. And those values should look like this. So what I did is I took the average of the spring constant number 2 and I used that for block number 4, 5 and 6 as well. I also used spring constant number 1, that was 0.61. I used that for blocks 4, 5 and 6 as well. Well, now you can use, it doesn't matter which one you pick, you can take the spring constant number 1 or spring constant number 2, and you can take the extension number 1 and extension number 2, but don't mess them up. So don't take the extension from spring number 1 and mix it up with the spring constant number 2. Again, I made a mistake over here, that should be a 2. So the thing that you should do is calculate this, and you should get these values 0.7, 1.5 and 2.0. So that is the gravity force of block number 4, 5 and 6. Well, the weight on block number 4 is 0.7 Newton, the weight on block number 5 is 1.5 and that one on 6 is 2.0. What I want you to do is calculate the mass in grams for each block. Well, that is hopefully not that difficult. The mass of block number 4, Well, that is the gravity force working on that block divided by the gravity. Well, we already calculated the gravity force working on that block. That was 0.7. We divided by 9.81 and we get a certain value, 0.071 kilogram. And I converted that into grams, so I multiplied it by 1000. Well, you do exactly the same calculation for number 5 and number 6, and these should be your values. Step number 10 is the last step. You need to try and answer the following questions. If you double the force exerted on the spring, will the extension of the spring also double? So please check the graph, what kind of graph you have, and check if the values get doubled if you double the other value. The answer should be yes, they are directly proportional, and that's why if you double the force working on a spring, the extension will be doubled. Well, that is already an answer to question number 2. How do we call the relationship between the extension and the force? We call that directly proportional. You always get a straight line running to 0. If you double one quantity, you always get another quantity will be doubled. And question number 3, which value is a constant value in Hooke's law? Well, actually, with all directly proportional relationships, you should get a constant. And in this situation, the constant was of course the spring constant for each spring. Well, I hope that you enjoyed this experiment. I'm going to try and make more of those movies so you can do the experiments at home. Make sure you finish this lesson for the start of next lesson. Thumbs up if you like this movie and make sure that you subscribe to my channel. Thank you for watching and hope to see you soon. Bye bye.